on one side of the wall, and I've got mostly chickens and ducks over here, and I've got all ducks over here. What's going to happen if I've got a fence in between those? Naturally, the chickens are going to go to one side to equal out the amount of chickens and ducks on one side versus the other. They want to create equal on both sides naturally. Water is the same way in those cell walls. Water is going to want to, if I have 50 TDS water over here and I have 500 TDS water over here, this is going to want to push more pure water across that membrane so that I create a balance of equal amounts of concentration on both sides. Does that make sense? It wants to do that so much that it will actually force pressure, and if these are at equal levels, it'll actually force pressure and push to where the other side has a higher level and volume than the lower concentration side. And that force is called osmotic pressure. So reverse osmosis, if that's osmosis and that's osmotic pressure, reverse osmosis is I'm going to take this over here that has, if it's 500 ppm, milligrams per liter, whatever it happens to be, and I'm going to take a pressure and push it the other way and push that water back across the membrane so that I create lower concentration TDS water on the other side. I'm going to reverse osmosis. That creates it requires energy. It requires some force to do that. I am overcoming osmotic pressure. So I have to have some force to make that happen. Where am I going to get that force from? Most of the time in a home, the benefit of the municipal water supply is that they're creating that force for me. What's typical line pressure for plumbing in this area? For
70 psi, Rusty? 70.
Okay, so 70 psi, that's where it's coming from. It's that line pressure from the city, that's 70 psi, that's I'm going to use to push water across that membrane. Okay?
And what is the optimum psi for a reverse osmosis membrane?
Optimum? I don't know the answer to that question. I'm sorry, Phil. I don't know the optimum pressure.
What are your membranes tested at?
Our membranes are tested, usually testing the standard, and it's kind of variable because I think manufacturers sort of have a determination, but it's usually between 55 and 65 psi is that window where they're tested at. Ours are tested at 65. The GRO membranes that I'm going to talk about are tested at 65 psi as an inlet pressure as far as what our production rates are and stuff. You'll see some out there that'll say tested at 60 psi. I want to say I've seen some that have been tested at 55 psi. But it's nothing crazy. It's not like, you have to put 100 psi on the test. And the GRO membrane will operate down to as low as 40 psi inlet pressure. Okay? Let's take a look at what this looks like. So what I'm going to do, so here's my water. Okay, now in that water, you have dissolved solids, right? Including things like salt. What we're going to do, because of osmotic pressure on this side of the membrane up here, I am going to flow water over that membrane, and only the water is going to be allowed to reverse osmosis and go across the membrane. I can do that. I can deadhead that water filtration across the membrane. I can just take a sheet of RO membrane and push water through it and make pure water on the other side. The lifespan of my membrane is almost going to be instantaneously gone, though, depending upon what the TDS level is. Because if I'm just barriering, I'm going to use a different word. If I'm just blocking the contaminant from getting through, my membrane is going to load up like this. And then you get other natures of membrane filtration, like creep and stuff like that. But the main thing to know is, if I just create a wall and try and pass water through it, the lifespan of that membrane is almost going to be instantaneously done. So instead, what I do is I flow water over the surface of the membrane and allow my concentrate to escape. I make water across the membrane, across one side, and then I allow my concentration to escape, to drain. So every RO system is actually making what's called a concentrate that is going to drain, along with the permeate, the product water, the clean water that it's putting into a tank.
What kind of ratios do you have?
Historically, that's been improving over time. When RO membranes were first produced, the ratio of that production, even in best case, was oft times in the neighborhood of 15 to 25 gallons of wastewater to 1 gallon of clean water. Now, over time, that's improved. Over time, that's improved. High efficiency ROs 10 years ago, would tout the claim of 3 to 5 gallons of water down the drain to 1 gallon of product water. Now, that's a big leap forward. Going from 15 to 25 to 3 to 5 is a big leap forward. Now, the newest product advancement that we have is what's called GRO. Okay, so GRO stands for green RO. We didn't go with green RO. When you say green, there's a bunch of people that expect that there's going to be a lot that goes behind that. If it's green, then it has to do this and it has to be that. You can't just say green anymore because it means something. So GRO is, when it's tested as a membrane on its own, it makes 1 gallon of treated water to every 1 gallon that it puts down the drain. So it's 1 to 1. Okay? So that's a membrane. So that membrane is encapsulated with this system. This is our FreshPoint RO system. That's the membrane. It's clean. It comes in a bag as a replacement. So it's all clean as far as replacements and stuff. You don't have to worry about getting contaminated. It all comes with double O-ring seals and so forth.
So it's 50 gallon per day.
That is
GRO?
Yes, that's right, Derek. That's what the 50 means.
So replacing that's as easy as what you just did?
Yeah.
Yeah, and I'm not very good at it, so it's probably actually easier.
That was pretty impressive. It was pretty quick.
If I can do it, you can do it. Gallon tank. This is a diaphragm tank. In the middle, it's welded together. There's a rubber diaphragm in between the two sides. On one side is air, which is pressurized right here. Got a regular little Schneider valve on here that you pressurize up. It's air on this side. We bring in water on the other side. Water pushes on the diaphragm and then pushes that diaphragm down until it equalizes pressure on both sides. These are pre-charged at about 6 psi of air pressure. So water comes in on this side, pushes that diaphragm down. Now the diaphragm is then going to be responsible for, when I turn on the faucet, the diaphragm is what pushes the water out. Because the membrane is such low production, that's why I have this storage tank here. That's why I have about 1.1 gallons of stored water in here. 1.1, 1.5, depends on what you're mixing. So this is a 3-stage RO. You can see that it's 3 stages. It has a pre-filter, it has a membrane, and it has a post-filter. It has an, what do we need to do to protect the membrane? It's a poly material. We need to protect it from chlorine, right? We don't want it to break down because of chlorination, so there's a carbon filter in there. And that's actually a DFX. What's DFX? Diamond flow, which is a sediment and carbon in one. So it's almost like a 4-stage because you have a 2-stage filter on the front. All right? 3-stage. 50 gallon per day membrane on the 3-stage. The 4-stage and the 5-stage that Jay brought up, the 4-stage and the 5-stage, which look just like this, only a little bit wider, the 4-stage and the 5-stage both have 75 gallon per day membranes. And the storage tank isn't a 2.8, it's a 4.2. So this gets a lot more, it has